Good morning, everyone. My name is Gianluca Zaza. I'm a researcher at Università of Bari, Aldo, Moro, and member of Spoke 6. Today, I would like to present my work titled Exploring the Expressive Power of Language Model in Neuro-Fuzzy System Explainability, a study on EEG-Based seizure detection. Explainability is one of the most important challenges in artificial intelligence today. It is essential, first of all, for increasing the transparency of AI models. Many AI decisions have a direct impact on people, for example, in medical diagnosis or job selection, and accuracy alone is not enough. Models also need to be understandable, so that user can trust them and clearly see the reason behind each decision. A second reason is that most modern AI models, especially in deep neural network, work like black box. We often don't know which factor influence the predictors or why they produce a certain output. Explainability helps us open this black box model and understand how the model actually works. Finally, explainability is also required by law. Both the GDPR and the new European AI Act demand transparent, traceable and explainable system that can justify the decision to users and regulators. Our work is based on the idea of combining large language model with a neuro-fuzzy system, creating a neuro-symbiotic framework capable of generating explanations that are richer, more structured, and easy to interpret. LLM can produce natural and detailed text, while neuro-fuzzy system provide rules and structures that make explanation more consistent. From this idea came two research questions of the study. The first, explore which large language model produced the best explanation in terms of fluency, coherence, and overall linguistic quality. The second one investigates which prompting strategies, such as zero-shot, persona pattern, or persona pattern with fact-checking, lead to clear and more context-aware explanations. The proposed framework works in 3 steps. The neuro-fuzzy system extracts rules and structured information from the EEG dataset. These rules are often transformed into a prompt and sent to a large language model, which produce an explanation. Finally, the generated explanations are evaluated using linguistic metrics and then reviewed by a human expert. This process creates a real collaboration between the human and the AI, creating a human-in-the-loop approach where human and machine work together to improve explanation quality. The results are quite interesting. In the zero-shot setting, 25 large provide the richest answer with a wider vocabulary, while the small 25 models are easy to read but less detailed. Llama 3 stand out as the most logical and the fastest. When we apply the persona pattern, the situation changes. 25 small improves significantly in diversity and readability, although coherence remains somewhat limited. Other models become more structured but less fluent. Llama 3 continues to perform well overall. When fact-checking is added, we see another general improvements in the quality of explanation. And the 25 small increases further in most of metrics, showing that fact-checking helps produce more complete and relevant content. In the conclusion, a single model excels in the all linguistic dimension. Each LLM has specific strengths that are often complementary. Some are more coherent, others rich in vocabulary, and others easy to read. However, Llama appears to offer the best balance between quantitative performance and qualitative evaluation. Furthermore, the persona pattern proves to be the most effective in prompting strategies, because aside the model a professional rule, for example, that the doctors help it generate more consistent, relevant, and meaningful explanations. For the future work, we plan to involve domain experts to evaluate not only the linguistic quality, but also the real and fullness of the explanations in clinical practice. We also aim to explore alternative physiological models to make the system even more transparent, interpretable, and accurate. Thank you for attention.